Hello students, now I am going to see about attenuation factor alpha for TM waves. So in the last session we have discussed attenuation factor alpha for TE waves. So now TM, and we know that the TM wave equations are Ez is equals to 1 by j omega epsilon minus C4 sin gamma x into e power minus gamma z. Hy is equal to C4 cos gamma x x e power minus gamma z. Next Ex is equals to 1 by j omega epsilon C4 cos gamma x of x into e power minus gamma z. Okay, so what we did in the earlier, just we have substituted gamma as j beta and gamma x as m pi by a. Substitute these two in above equations such that I'll get Ez is equals to 1 by j omega epsilon minus C4 sin m pi by ax into m pi by a e power minus j beta z. Next Hy is equals to C4 cos m pi by a x e power minus j beta z, and Ex is equals to 1 by j omega epsilon and gamma as j beta into C4 cos m pi by a into x into e power minus j beta z. Okay, now the magnitude of current density for parallel plane waveguides. For parallel plane waveguides will be equal to the tangential component of electric field intensity, that is Ez. In the last session we have considered Hz, now it is Ez. Okay, so Ez is nothing but this equation. So here magnitude of Is from the above equation is nothing but C4 into m pi by a omega epsilon. Okay, now the same process we have to follow. Whatever we did for the calculation of attenuation factor for TE, the same we have to do for TM. So power loss per unit length for two plates. For two plates I am directly calculating, that is power is nothing but always I square Rs. Is square into Rs, that is nothing but C4 m pi by a omega epsilon whole square into Rs. Next we have to calculate power transmitted. So power transmitted per unit area is nothing but half modulation of E cross H star. Okay, so here half. So electric field intensity I am having Ex Hy. Okay, so I got here Ex Hy, and no need to put minus symbol because I am having the electric field intensity along x direction, magnetic field intensity along y direction. That is the basic transform nature of electromagnetic wave. Okay, if we are having these suffixes different like EY, HX, then we have to place negative sign in the formula minus. Okay, so now it is C4 square beta by omega epsilon cos square m pi by a into x. So here power transmitted per unit area is equal to same, and directly placing 1 by 2 here. Here this is the power transmitted per unit area. So here as we are involving the cos terms, we have to take the integration from x is equal to 0 to a, and this is C4 square beta by omega epsilon into cos square m pi by a x into dx. So here cos square theta can be written as 1 plus cos 2 theta by 2. Okay, here 1 by 2 C4 square beta by omega epsilon. By 2 C4 square beta by omega epsilon integration x is equal to 0 to a. Cos square theta can be written as 1 plus cos 2 theta by 2 to dx. So 1 by 2, 1 by 2, 1 by 4 C4 square beta by omega epsilon x is equal to 0 to a. Okay, directly here what is the integration of 1? 1 integration is x plus cos integration is sin m pi by a by 2 into m pi by a, x is equal to 0 to x is equal to a. So this term will be equal to 0. So 1 by 4 C4 square beta by omega epsilon. So I am directly substituting x is equal to a. Now alpha is equals to power lost per unit length. What I got power lost per unit length? C4 m pi by a omega epsilon whole square into rs divided by, this is the power transmitted per unit area, 2 into 1 by 4 into C4 square beta by omega epsilon into a. So if I simplify this equation, I will get 2 m pi by a whole square into rs divided by omega epsilon beta. This is the attenuation factor in a case of transverse magnetic waves. Thank you.